So in the next question we have the point -3, 5, and it's on the terminal arm of the angle in standard position. So let's draw that. So this is the Cartesian plane. Our point -3, 5 would be around here. And this would be the terminal arm. So the angle that's in standard position that we're trying to find, angle theta, well, that's this angle right here. This is our angle that's in standard position. This is our principal angle. And in order to find that angle, we need to create a right angle triangle from this terminal arm. Because we can find this angle right here in this triangle, in this right angle triangle, this is just our beta angle. It's just our related acute angle. And on our triangle, since we know this is the point -3, 5, this bottom side is -3, and this side on the left is 5. So since this is a right angle triangle, we can just use one of our trig ratios to find out what beta is equal to. So we have our opposite side to beta and our adjacent side to beta, so that just means that we can use tan. So the tan of beta is just equal to the opposite side over the adjacent side, and that's just equal to 5 over -3. Now if you just put that in your calculator, you might get something that's negative, or you might get an angle that doesn't even make sense. Well, let's just focus on the triangle that we have, the right angle triangle, and not where it's placed on the Cartesian plane. So the side lengths of this triangle, the opposite side and the adjacent side, is just 5 and 3. Ignore the fact that it's negative. So we're going to change this -3 into a positive and use that number when you plug it into the calculator. So we're just going to make tan of beta equal to 5 over a +3 instead of a -3. Because in a triangle, can we have one of the side lengths to be a negative number? Does that make sense? Well, it doesn't. That's why I want you to just focus on the triangle and focus on finding this acute angle. So the measurement, the side length of this side down here is really just a +3. So that's why we're using a +3 instead of this -3. So we need to use the inverse of tan and put that into our calculators, and you're going to get that beta is just equal to about 59 degrees. But that's this angle beta, that's our related acute angle, and we're being asked to find theta, the principal angle. So in order to find theta, we need to subtract our related acute angle from 180 degrees. So theta is just equal to 180 degrees minus 59 degrees. And that means theta is just equal to 121 degrees. And that's it. That's our principal angle. So whenever you have another question like this, you need to plot your point on the Cartesian plane, and then you need to use the measurement of the related acute angle to help you find the actual angle that's in standard position. So in the next question, our point is -2, -4, and that's on the terminal arm of angle theta. So -2 and -4 is right around here. And this is our terminal arm, and we're looking for this angle theta. Well, we know that this is 180 degrees, but what's the rest of this angle? Well, we can draw a right angle triangle, and then the rest of this angle is just our related acute angle. It's beta. So I want you to pause the video and do it on your own. Use this triangle and use one of your trig ratios to find the measurement of beta. So if you're just coming back to the video, you should have used tan to find our angle because we have our opposite side and our adjacent side to angle beta. And I just used a +4 over +2, just focusing on the side lengths of this triangle to get what this acute angle is. So using our inverse of tan, beta is equal to 63.4 degrees. So in order to find theta, since our related acute angle is outside of this 180 degrees, theta is just going to be equal to 180 plus 63.4. So that means theta is just equal to 243.4 degrees. In the next question, we have the point 2 and -3 on the terminal arm of angle theta in standard position. So that point would be somewhere over here in this quadrant 4, and angle theta in standard position would be this whole thing. So think about how you would find the measurement of this whole angle. So I want you to pause the video and try it on your own, then come back to the video to check your answer. So if you're coming back to the video to check your answer, you should have drawn a right angle triangle here using this point. So we're finding that related acute angle. So you should have noticed by now that the related acute angle is very useful. So it's really important to understand what the related acute angle is. So we're using trigonometry to find the measurement of that related acute angle, and you should be using the tan ratio. So tan is equal to opposite over adjacent, so we're just using that tan beta is equal to -3/2. And remember, we're going to change that -3 into a positive, just use the positive measurement of that side length. So it's tan beta is equal to 3/2, and you're using the inverse of tan to get the measurement of beta. So the angle beta is just equal to approximately 56.3 degrees. Okay, great. So we found the measurement of our related acute angle beta, but how do we get the measurement of angle theta? Well, out of the entire Cartesian plane, the entire 360-degree angle, we know that angle beta is 56.3 degrees. Theta is just everything else. So you should have done 360 minus our related acute angle, so minus 56.3 degrees, which means theta is just equal to 303.7 degrees. Okay, and that's just the measurement of theta in standard position. And the next question is a little bit different. So given that sine theta is equal to -2/5, where theta is greater or equal to 0 degrees and less than or equal to 360 degrees, we need to evaluate all possible values of theta. So you might be thinking, what do you mean by all possible values of theta? There's more than one angle. Well, we know something now called the cast rule. So let's actually just start off by drawing our Cartesian plane. So in our Cartesian plane, we have 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And the cast rule starts in quadrant 4 and goes counterclockwise. So we're using the cast rule because we need to look at our sine ratio that's given to us. Our sine of theta is equal to -2/5. So our ratio is negative. So which quadrants has a sine ratio that's negative? Well, A means that all of the ratios are positive in the first quadrant, and S means that sine is the only ratio that's positive in the second quadrant. So in quadrant 3 and quadrant 4 is where our negative sine ratio is. So our angles must be here somewhere. Theta always represents our angle in standard position, so our cast rule says we have 2 possible angles for theta. We have this first angle, and then this second angle that's much bigger. So we're being asked to find the measurement of these 2 angles. So how are we going to do this? Well, if these 2 angles share the same ratio, the ratio is -2/5, well then that means that the related acute angle is exactly the same. So we can find the measurement of beta by using the sine of beta is equal to -2/5. And you can put that in your calculator using the inverse of sine, and you're going to get a negative angle, and that's this angle right here. But we've been using the positive version of this to just give us the measurement of our related acute angle. So we can still do the sine of beta is equal to 2/5, and you're just going to get the measurement of our related acute angle. So when you use the inverse of sine, you're just going to get that beta is equal to 23.58 degrees. So now we know the measurement of our related acute angle. That means we know that the measurement of these 2 angles right here, beta, are both equal to 23.58 degrees. And now we just need to find both of our angle thetas. So our first one is in quadrant 3, so that means we can just take 180 degrees and add our angle beta. So theta 1 is equal to 180 plus 23.58, and that's just equal to 203.58 degrees. And then our second angle is in quadrant 4, so that's just 23.58 degrees away from 360. So that means we can just do 360 degrees minus 23.58. And then you just get that our second angle is equal to 336.42 degrees. And we're done. These are our two angles between 0 and 360 degrees that have this ratio for sine. So here's our next question. We need to find all possible values for theta, where theta is in between 0 and 360 degrees, and the cosine of theta is equal to 5/6. So here's our Cartesian plane, and we need to use our cast rule because we're finding all our possible angles in between 0 and 360 degrees. So cast rule starts in quadrant 4, it goes counterclockwise, try not to forget that. And we're looking for all of the quadrants that have a positive cosine ratio. C means that the only ratio that's positive in quadrant 4 is cosine, and A means that all of the ratios are positive in quadrant 1. And then these are our two possibilities for theta. Since these two angles do share the same ratio, our related acute angles are the same. So we can just use the cosine of our angle beta is equal to 5/6 and put that into your calculator. So when you use the inverse of cosine, you're just going to get that beta is equal to approximately 33.56 degrees. So let's just go back and look at our diagram. So our first angle is in quadrant 1, and our related acute angle, our angle beta, is the same thing as our first angle theta. Well, when you have an angle in standard position that's in quadrant 1, that principal angle is the exact same angle as your related acute angle. So that just means theta 1 is equal to 33.56 degrees. And our second angle is in quadrant 4, so we just need to take away our related acute angle from a full 360 degrees. So theta 2 is equal to 360 minus 33.56, and that's just equal to 326.44 degrees. And there you have it. Those are our two angles that are in between 0 and 360 degrees that have this exact trig ratio.